Ladies and gentlemen, class recording has started. So, yesterday, we began our discussion of motion in two dimensions. And we saw several examples and talked about several examples of the fact that when an object is moving in two dimensions, it is doing two things at the same time. There's a vertical motion, there's a horizontal motion, and those two things are happening simultaneously. But they also don't affect one another. They are independent of one another. Yes, they're occurring at the same time, but just because one is occurring doesn't mean it affects what the other thing is happening. That means that when we go to analyze the motion of an object moving in two dimensions, we have to look at two different aspects of that motion. We have to look at the horizontal aspect and we have to look at the vertical aspect separately because they are independent. Sometimes we'll see there's some crossover, but when we're looking at analyzing the motion in two dimensions, we have to look at two factors, the horizontal stuff and the vertical stuff. Okay? Good there? We are going to start today on page 133 of your book.
Pardon the interruption. This is the last call for picture retake. If you have not gone down to do picture retake, you need to do so now because they will be leaving. So picture retake, last call.
All right, so on page 133 of your book is an example, example 4.9, that is similar to the girl on the rollerblades that we talked about yesterday, but this time it's a guy on a skateboard with a basketball. So it says, a person skateboarding with a constant speed of 1.30 meters per second releases a ball from a height of 1.25 meters above the ground. Given that the initial or exit initial is 0 and y initial is 1.25, find x final and y final for the time 0.25 and 0.5. So we are going to focus here on time of 0.25. Okay? So first, before we talk about how we're going to do this mathematically, let's talk about what is going to happen. Okay? So this ball is being held by the guy on the skateboard. And that means that it's traveling in this direction, right? Because the guy on the skateboard is traveling in that direction. But as soon as the guy on the skateboard lets the ball go, what starts affecting the motion of that object? Gravity, right? So what is the ball going to start doing? Falling and moving downward and accelerating as it moves downward, right? But if we look at the horizontal aspect, once the guy lets the ball go, he can't affect its motion anymore. If gravity is the only thing acting on the ball and gravity acts up and down, is there anything acting side to side? If there's nothing acting horizontally on this ball, what is it going to do? No, because, it's not going to drop straight down because what was it doing originally, Julie? It would drop straight down if it wasn't doing anything side to side, right? But if it was moving horizontally, right, the fact that gravity is acting on it, is that going to change the fact that it was moving horizontally? Because gravity acts which way? Up and down. Up and down things don't affect side-to-side things, that whole independence of motion, right? So this object is going to continue to move in the horizontal direction even as gravity is pulling it downward and causing it to accelerate downward. That's why we end up with this curved path, which we said yesterday takes the shape of what? It's a parabola, right? In this case, it's only half of a parabola, but it's still parabolic. Okay? So, here's how I like to break this problem down, and I think it works well if you guys do it too. We said that There are two motions occurring simultaneously, a horizontal motion and a vertical motion. And therefore, we need to analyze each of them separately. So we're going to start two lists, an X list and a Y list, for horizontal stuff and for vertical stuff. Now, the things that we look for, the factors that go into affecting that motion, are the same. We call them the same thing, but they're different horizontally and vertically. Things like, well, where exactly did this object start? So what was its initial position on the x-axis, and what was its initial position on the y-axis? Where does it ultimately end up on the x-axis and the y-axis? These are questions that we want to know. What was it doing originally when this situation started? What does it do eventually in this situation that we're looking at? What's causing the changes to the motion of this object? And then, how long do all these things last? Okay. These 6 factors are the things that we use to describe motion, right? Just in the case of the projectile motion, we have to look at the things that are affecting the horizontal motion and the things that are affecting the vertical motion. Okay? So, first things first, right? What are we looking for in this problem? It says we want to find x final and y final. So, this is a question mark on the left-hand side, and this is a question mark on the right-hand side. Where does it end up on the x-axis? Where does it end up on the y-axis? Now that we have established what we're looking for, now we can start looking at other information that we have in order to help us find out what we're looking for. For example, first thing, pretty obvious, right? It tells us that we want to know where this object is at time 0.250 seconds. We have a row here for time, right? 0.250 is which time? The horizontal time, or is it the vertical time?
Horizontal.
No, it's the vertical.
It's actually both. Because we said that horizontal and vertical occur simultaneously, right? So, when we make this chart, if we know a time value, this time value has to be the same for the horizontal and the vertical. It's the only row on the table that has to be the same from one side to the other side. Sometimes we'll see that other things turn out to be the same, but that's just sort of coincidence. The time has to be the same. Okay? Good there. All right, next. We kind of talked about, at the moment that this guy lets the ball go, what's affecting the motion of the object? What's affecting the motion of the ball? Gravity. Gravity acts which way? Down. Which axis? X or Y? Y. Okay? So, and we know that gravity causes an acceleration of 9.81. Okay? But yesterday, if you go ahead. Yes, because yesterday we talked about that when we do this problem, we have to set up a frame of reference that accounts for both the x's and the y's. So we said that we look at the frame of reference in this problem as being like an x and y axis from math class. Okay? That on the x-axis, this is the positive x direction, and this is the negative x direction, and this is the positive y direction, and that is the negative y direction. Same thing, like I said, because this gravity is pointing downward, we give it what sign? Negative. So the acceleration here is negative 9.81 because it goes down on the y-axis. But we said, is there anything else affecting the motion of this ball? Is anything else acting on it once the guy lets it go? If we neglect what? Air resistance, right? Logan, like I said, like that was Logan pointed in this direction, right? Okay. But once the guy lets the ball go, can he affect its motion anymore? So the only thing that's acting on it is gravity. Gravity acts up and down, and it causes an acceleration on the y-axis. But is there anything causing change on the x-axis? Is there anything to change the horizontal motion of this ball? No air resistance. Right? So if we don't do air resistance or friction, okay? Is there anything else here to change the motion horizontally? If there's nothing to change the motion, what is the acceleration? Okay? The acceleration on the y-axis is going to, or x-axis is going to be 0. This row, right here, with those two values, that's going to be the same for every problem that we do in this section. Because if we're saying something's a projectile, we're going to say it's only gravity that's affecting its motion. Gravity causes that acceleration on the y-axis, but there's nothing on the x-axis to change its motion. So the blue row is always going to be the same. Okay? We can almost fill that in immediately when we make our chart. All right, there's some other things that we can fill in based on this picture and the information that they gave us. What's one other thing that we can tell from this picture and the information they gave us in the problem? Y initial is going to be what, Anthony? Say again? What is 1.30? Let's start with that then. Okay. What unit does 1.30 have on it?
Meters per second.
That means it's going to be a what? A velocity, right? Which velocity initial? Initial. Which axis, Nina? X. Because this ball is moving horizontally, right? It's still falling off that.
Yeah, that's what I'm thinking.
So that's right. Yeah, see, that is my fault. It's been falling off like pretty much all period, but because I've been standing over here, like some people are paying attention and looking over.
Yeah.
Some people are daydreaming out the window, but you know. So.
I thought it was actually
I feel like
snowing.
it's like
Okay. So in this, let's do the velocity first. Okay. So we said this 1.3, right? That's the velocity, but it's the velocity horizontal. Okay. Which direction is it going on the horizontal axis, Nina? Okay, so it's positive 1.30. Okay. At the moment that the skateboard guy lets the ball go, which way is it going?
Down and to the right.
Not at the moment that he lets it go. On the very instant he lets it go, which way is it going?
Oh, down. Oh, I mean, just the right.
At the very instant that he lets it go, it's traveling to the right. Is it moving up or down yet? No. Meaning, what is the initial velocity on the y-axis going to be?
0.
0. This is a specific type of projectile motion problem that we call a horizontal launch, right? Back to what we talked about. You just did that, right?
Wait, are you talking about like the instant
The very
right before he lets it go, or
no,
as he's letting it
the
go?
very instant that it is let go.
It doesn't hang there for it all though. It
No.
just drops.
Yes. It starts dropping immediately after it gets let go.
Yeah.
But the very second, the very moment in time when I let this ball go, right? This is a problem we did back in the last unit, right? If I let this go, right, gravity causes it to accelerate downward. But the very instant that I let it go, was it moving?
People can debate about that.
No, you can't.
Do it again. We need a physics debate.
So think about this, right? We said that acceleration relies on two values, right? This is a question from the test, right? Just because it's accelerate? Is it accelerating the moment that I let it go?
Yeah.
Because it starts to move immediately after. But the instant that I let it go, it's not doing anything.
Okay.
Okay? In this problem, if the guy is holding it and he is traveling horizontally,
He was already skateboarding.
so that,
let it
yeah,
go.
he's moving, right? It says a person skateboarding with a constant speed, right? But if it's going in this direction, it's not doing anything vertically. And that's why the initial velocity on the y-axis is 0.
When you instantly let it go,
Yep.
isn't gravity instantly gonna be affecting on it?
Yes.
That's, God, it doesn't make sense.
So
That's what's confused me. 'Cause
that means it instantly starts moving,
Yeah.
but at the moment that I let it go, it wasn't doing
I mean,
anything.
I understand what you're saying. It's just like, that's so weird that.
But, that's how we have to do it, though.
Yeah.
So, 2 more things that we know. Anthony, what's one other thing that we know? We know the y initial, right? Where does it start on the y-axis, Anthony? Positive 1.25, right? It starts 1.25 meters above the 0 point, right above the ground, on the y-axis. But on the x-axis, where does it start on the x-axis? If we took the x and y coordinates of this spot right here, right, it would be 0x and positive 1.25y. Therefore, the initial position x is 0. Okay. Good there? Going back to yesterday, we said that in a case when this object is moving in 2 dimensions, we need 2 equations to analyze that motion. These equations apply to an object that is accelerating, right? But we look at the x-axis separately and the y-axis separately. It wants us to find x final and y final. So let's start with the x-axis, okay? In order to find x final, we have to know everything else in this equation, right? Do we know the acceleration on the x-axis? Yep.
Yeah.
Do we know the time that this is happening?
Yes.
Yep. Okay, so that takes care of that. Do we know the initial velocity on the x-axis?
Yeah.
Sure. Do we know where it starts on the x-axis?
Yeah.
Absolutely. So we can go in now and we can figure out where does it end up on the x-axis. So x final equals. Now, in this case here, right, what did we say the acceleration on the x-axis was? What happens to this whole term?
Wait, 0.
This whole term goes away, right? No, go ahead.
Do we not have to know the V final then for each of them?
In this case, the problem did not ask for that, right? Okay? So, Dylan, in this case here, this equation solves us for x final, right?
Yeah.
Does v final show up anywhere in that equation?
No.
So if we don't know it, at this point it's not a big deal, okay? Guess what we're going to do tomorrow?
V final.
V final, okay? So, in this case, right, the acceleration on the acceleration on the horizontal axis is 0, right? So that just goes away, okay? We know the initial velocity on the x-axis, it's 1.30. We know the time that that object goes under the influence of, or being a projectile. We plug that in there, and we said that the initial position on the x-axis is 0.
Now let's see the question. What's the difference between V final and X final?
You tell me, what's the difference between v final and x final?
What's V saying?
Velocity.
Okay, so that's what it's doing at the end of this section.
Yeah.
But what does x stand for?
Oh, where?
Where,
Okay.
right? So it's a difference between where and what.
Okay.
So that's how far it moves on the x-axis, right? Yeah. Here, right, to find y final, which is what we're trying to solve for, right, we need to know all the rest of the things. Do we know acceleration on the y-axis?
Yeah.
We know the time, right? We said that the times have to be the same, horizontal and vertical. Do we know the initial velocity on the y-axis?
Yeah.
Yeah.
Yep. And we know where it starts on the y-axis. So we start plugging in things we know, right? Y final equals 1/2 times the acceleration, which is negative 9.81, times t, which is 0.25. We've got to square that t, right? Plus, but what did we say was the initial velocity on the y-axis? What was happening initially on the y-axis?
Nothing.
0, right? Nothing. So what happens to this whole term?
0.
That term just goes away. And then we end up here with 1.25. We plug that in, we should end up with, I believe, 0.96 meters.
That's about right.
What is it, 0.94?
And then 0.943 meters.
Okay. This is how far the object moved horizontally. Is this how far the object fell during that time?
Yeah.
No. Right? This is where it ends up. But where did it start on the y-axis? It started up here, right? 0.125. So if we want to know how far it actually fell, what would we have to do?
Subtract.
We'd have to subtract, right? To do a little subtraction. Got it? Now, this, right, we said is the final position, but not the displacement, right? The displacement looks at how far it actually went. Okay? Good there? You guys did not get as far as some of the other classes, but you guys had good questions and we had good, good discussion. So tomorrow we will do a couple more examples, and I think I'll give you some time in class to work out the problems on your own before we get into the lab. Okay?